the button. It's giving me the stupid message that it's still not working. I know the microphone's not working, but hopefully it's going to stay recording. Okay, I think we're good. Okay, for statistics in chapter 3, now that's not going to work. That's awesome. Maybe I need to push that one. Okay. Oh my goodness. Okay, now let's hope our little clicker deal works. I lost something else. Okay, so in chapter 2, what we were doing is finding ways to organize raw data using graphs and charts. So now we're going to do measures of central tendency. So if the average shoe size is 10, the store would only need that shoe size. So that's where central tendency comes into play, which is not true, right? Then we're going to talk about measures of variation in the next piece. So variation is why are those shoe stores actually carrying more than just size 10. Okay, so that's a measure of variation. Measure of position is like what percentile you're at. So you guys have all gotten results back on things that you're at this percentile. Okay, and then the last section is exploratory data analysis, which I don't know why it's skipping so fast, because that's weird. Exploratory data analysis, so you don't need to really write all that stuff down. But today we're going to do measures of central tendency. So there's 2 different types of things that we're going to be talking about in everything, and it's going to be either a statistic or a parameter. A statistic is a characteristic or measure obtained by using the points from a sample. Okay, so most of the things that we talk about are going to be using samples. However, sometimes we talk about a population. So a parameter is about a population. Okay, so if I talk about, I know the parameters for this problem, it's that they know everything about it. Okay, so when we do like a census, we find those parameters. When in between those 10 years, when we're talking about those differences, we're talking about statistics. Generally rounding, don't round until your final computation. So if that means keeping everything in the calculator so that you don't have to write it all down, that's fine. And your calculator will just keep track of it. And also make sure in the book they generally round about 3 or 4 decimal places out, but they do round a little bit. And that's just because they've actually gone and done enough math to realize, this piece doesn't change my final number. So with you guys, go out even like more than what the book does, because sometimes they don't always have it all the way. So let me see if I can do this stuff. Okay, you guys got that written down almost. And I think I put it in somewhere else, but we will always be rounding 1 more decimal place with everything that we do. When we actually have to do computations, when it's just like different things and we just have to find a number, then we're just finding the number. Okay, so the mean. We've all done the mean before. This is the gross looking way. The difference is, so when we have statistics, when we do samples, or parameters, or populations, we just denote it with a different variable. The main variable is here, x bar, x with a bar on top. We say that x bar is, or sometimes we actually would say the sample mean is. So if I say the sample mean, make sure you're writing x bar. If I say the population mean, which usually I won't because that's a longer word than saying this guy is mu. Mu. It's mu. It's the Greek letter m is basically, and that's a lowercase m basically. Whenever we do any sort of statistics, our populations are always with Greek letters. Roman letters are our Roman alphabet is what we use, and those are for samples. So just kind of remember that. Greek is for entire things. So this one's mu. Yeah, I don't know if you'll ever hear me say the population mean because mu is much shorter.
What's the difference?
So the difference would be if I wanted to know, there's no difference in how we calculate it. It'll just generally be about how the wording of the question is. If we were talking about Genoa Hugo School, we wanted to find the average age, how hard would it be to go actually ask everybody? Not very hard. So what we're gonna do if we're talking about Genoa Hugo School as our population, we're gonna go ask everybody. So our value would be mu equals whatever that average is. Okay? If I wanted to say, hey, my average Genoa Hugo School population, but I don't really feel like going and asking everybody, so I'm asking you guys, what's your guys' age? You know, I'm gonna average that out. I'm gonna say that's X bar. Okay? So it's same, I'm only adding 3 numbers together instead of however many kids we have. But that would be that difference. So, okay, mean should be rounded to 1 more decimal place than the raw data. And even if it came out to an even number, you should write like 0.0. I'll show you in an example. But do like 0.0. That way I know that you've actually took it into mind. Maybe not. Okay, so the data shows the number of patients in a sample of 6 hospitals who acquired the infection while hospitalized. Find the mean. So we're going to add all these up, and then we're going to divide by 6 because there's 6 things, and I think I actually put it on there so that we didn't have to find calculators during it. Okay, so the sum of the x's is the gross way that it's written. So if you see like the definition, when you see this, it's sum of the x's over the number of points you have. So the sum of the x's just means add all of your points up. Okay, so sometimes we'll see gross looking things like that, but don't get freaked out just because you see that. And that's a Greek S for sum. Even though it looks like an E, it's an S. I know what you mean when you say big E, but yeah, so S for sum. So add them all up. How many points do I have? Divide that. You guys have done that for a long time. So like this example, we get 64.8. So what I was meaning, if you got just 64, if you got your answer is 64, but all our data points were whole numbers, do 0.0 just to say, oh look, I've taken into thought that I have to round 1 more decimal place. And that way, at least if you've done that, if you make a different mistake, I know you're not thinking about that mistake. You're not going to do that mistake.
What's the difference between the little n and the big N?
Population or sample. And I pretty well use them interchangeably. Different formulas will do different things. No, she said N. Okay. One of the weird things that we've done, you've probably done it a little bit in middle school, maybe depending on when you've done it, is group data. So group data would be like those frequency distributions with like real numbers. So the first thing we have to find, let me try to show you, I have it on here somewhere. This is the gross formula. The sum of the frequencies times the midpoints is what that guy means over the number of points. Okay, so the first thing we need to do is find our midpoints. What? Yep. So midpoints is the first thing we have to find. So they kind of have this table set up for you. You don't have to do it in a table form. I don't think I usually would have. Midpoint, so 5.5 plus 10.5, divide that by 2. So 8, does that seem right? 16 divided by 2 is 8. Okay, so we have to know all our midpoints. 10.5 plus 15.5, 13, so 26 divided by 2. And because of the way it's grouped, it is, each class has a width of 5, so try to pay attention to that. As soon as I find a couple of those midpoints, I'm basically adding that value. So 8, 13,
18, 23, 28, 33.
How far am I? This goes with this, this goes with this, this goes with that. Oh, I actually did kind of stay even. And 38. Okay, next thing we're doing after we find the midpoints, is multiplying those midpoints by the frequencies. Okay, so multiplying those midpoints by the frequencies, 1 times 8 is 8. 2 times 13 is 26. 3 times 18, 4. 5 times 23, 112, 115, 120?
115.
Yeah, 115. 4 times 28,
112.
12, well, yeah, I'm not there. 3 times 33, got that one. 2 times 38,
76.
okay. So now what we need to do is we need to sum that up, that's what that big E thing means. Find the sums of the multiplications. So on that.
Yes.
Yes, what happened? Oops, okay, I want to go back. Can you sum those up for us? You slackers. I don't want to do it at all. There's not any nice groupings.
490.
490, okay. So we get 490 for our sums. So what we have to do with that is, we already multiplied them. Okay, so now we're putting that over the number of points. Don't think just because I have 1, 2, 3, 4, 5, 6, 7 classes, we're not dividing by 7, we're dividing by actually how many numbers we have. So we actually have to sum up the frequencies, which kind of seems weird because it really isn't a sum, it's just how many did I actually have. Okay, so we have 490 divided by 20. Okay, and that's why it's kind of nice to put it in this table, so that you can do that and not accidentally divide by 7.
24.5.
24.5.
Do you have to add another decimal unit there?
No, because not for group data. Don't do it for group data. If you have like single data points, yes, do it.
Okay.
This is just kind of a weird thing right
I'm
out.
17.0 years old.
But you're not 17.0. You're probably like 17.2.
No. My birthday's today.
Is it really? I can't lie. I feel like you might be lying because I feel like you already had a birthday. Okay. Median is. I have to remember this.
Nobody knows my birthday.
I thought it was like November 20th or something.
Oh,
I have no idea. December 20th? I don't know your birthday. I'm sorry. Kat would have known your birthday if she was here.
January 18th.
Okay. Median. We've done a lot of medians before in the past. What was that? Is that me? Weird. Okay. A midpoint of a data array. Make sure things are in order. Select the middle point. Select the middle point if it's an odd number. So everything's in order. Okay, it's just our middle number. Those are nice and easy. The even numbers, don't forget what we're actually doing is finding the mean of the middle 2 data points. So when we're talking about things in this class, we're going to use the word mean, not the word average, because average is just kind of this generic term that could use mean, median, mode, or also mid-range. So we're not going to use the word average. We're going to try not to. I might try not to. If I do it, I will mean. Okay? So everything's in order, but this is where my middle needs to be, so I'm averaging those. I add them together and divide by 2, so I don't even know if like you guys can see this stuff. So I don't think you'll have problems with that. And we'll do like an actual example in a couple minutes. Okay. It's really weird because I have like 2 different clicker things. Okay, mode, data that it values that occur the most often. If it's something is unimodal, it has 1. If it's bimodal, it has 2 modes. If it's multimodal, it has more than 2. So that was kind of with those distributions. Unimodal has 1 hump, bimodal will have 2 humps. We don't really see a lot of distributions that have more than that. Okay, used when the most typical result is desired. So just kind of depending on what it asks you. So find the mode for the number of branches that the 6 banks have here. So 401, 344, 209, 201, 227, 353. Did any of those repeat?
No.
No, what is the mode then?
Nothing.
0.
Not 0. It's nothing. You can say there's no mode.
0.
Don't say it's 0. Okay, so be really careful about that. That was the reason that that example is there. Okay, 0 would actually be, if 0 is not the point. Okay. So this data shows the number of licensed nuclear reactors in the United States for the recent 15-year period. I don't think it really is recent anymore. In some 15-year period. So I see a lot of 104s. I see 1, 2, 3, 4, 5. There's 1, 2, 4, 5 109s. So 111s. There's 2 of those. I only care about the one that occurs the most often, even though 111 repeated. We don't care about that one. So we're gonna say it's bimodal, and it's 104 and 109. Okay. So that is okay to have as well. When we talk about classes, that's group data, like the one, this is the same one we just looked at. We can't actually pinpoint a single data point. So what we look at is we call it a modal class. M-O-D-A-L. Class. Okay. Mid-range, it seems like nobody ever actually does mid-range. They talk about range a lot, but range is not actually a measure of center, whereas mid-range is. So the mid-range is we just do the low plus the high divided by 2. Where can I just click? Okay. If the low or high is really big or really small, you get weird mid-ranges, so it makes it not very useful. Whereas sometimes it actually could be a useful sort of thing. Mid-range, so we just have MR, 1 as our low, 8 as our high, divided by 2. 9 divided by 2, 4.5. Okay, weighted means. The way we use weighted means a lot is, really good example is just finding your grade point average. It's pretty similar to the group means. We multiply numbers together, find the sum, divide them by however many, the sum of our weights basically. So it really, really is similar. I don't know if I have more than that. I think that's it. So, X bar depending on if you're doing samples or populations. I think usually we'll use X bar unless it says the population data is this. So then I'll show you the wording of one of those in a couple seconds. Okay, so grade point average. So a student received an A in English composition for 3 credits, a C in Introduction to Psychology for 3 credits, B in Bio 1 for 4 credits, D in PE for 2 credits. This is like the most terrible student that's ever existed, I guess. Assuming an A is 4 grade points, B is 3, C is 2, and D is 1, and then F is 0. So if you guys ever actually have to do a grade point average, you'll use the same weights unless it tells you otherwise. Okay, so our weight is how many credits it was for, and our grade is whatever letter we got. Okay, so we basically have to give everything a number value for this to work, so we can't be like 3A or 3C. That doesn't work. So we take it and we do out 3 times 4 plus 3 times 2 plus 4 times 3. I keep freaking out that I hit the button on accident. 2 times 1. Okay. Usually you have to take a PE class in college. Please don't get a D in it, you guys. Okay. Divided by the sum of the weights. So that's 3 plus 3 plus 4 plus 2. Okay, so I have 12 plus 6 plus another 12 plus 2 all over 3 and 3 is 6 and 10 and 12. Which, adding that up again, I get 2432 divided by 12. I don't know that one. 2.6. 2.6? Okay. 2.66, so you could do like a repeating sign on it, whatever, I'm fine with that. I'm not gonna be too picky on that. So that's how we do weighted means. Whoops, let's do what kind of some of these things will look like graphically together. And graphically, I will generally put questions similar to this with words. Okay, so if it is a symmetric or a normal distribution, we'll talk about later on. So it's symmetric, unimodal, median, and the mean are all about the same. Okay? Or they all are the same. Okay. Types of the other one, positively or right skewed. I don't like the word positively skewed because I think it's harder to remember. Right skewed, remember right-tailed. So it kind of is down further that way. Goes out that way more. So a right skewed distribution, the mode is generally less than the median, which is less than the mean. Okay? And the weird thing is about that is that the mean, because usually if I have something right skewed, I'll have like one big number out here. So the mean and median are more affected by outliers. So median and mean and mid-range. The median is not so much, I'm sorry. The mean is more affected. By outliers. We'll talk about outliers later on too. I don't know that we really do in this chapter. I've always kind of heard the term before. It's something that's way out of there, but we'll actually be finding what actually is considered an outlier. But something way out there. So if I had an outlier on this guy, it'd be like way down here or maybe even further down depending on where my scale is. Okay, if it's negatively or left skewed, my tail's on the right side, my mean is generally the lowest thing on there. So my mean is lower than my median and my mode. Okay, and the mode is going to be like this. This is the highest one, so that's my mode. My mode is that highest class. That's my modal class. Okay, let's find mean, median, and mode, and we'll also do a mid-range for this as well. So this is like some of how the wording will be. A small company consists of the owner, the manager, the salesperson, and 2 technicians, all of whose annual salaries are listed here. Assume this is the entire population. So when it kind of says that, or if it did, even if it didn't say that, this is everybody in the company, that means I'm looking for my mu when I find my mean. So my mu is equal to all of these guys added together. I'm not going to write it all out, so I have 50 plus 20 is 70, 82, and yep, right at 100,000. So I have 100,000 divided by 1, 2, 3, 4, 5. Divided by 5 points. So the average salary, the mean salary is $20,000. Okay, then finding the median, it's all already in order. The median, since it's an odd number, is just that middle number. Median really doesn't have any like fancy letters. Sometimes if you...
Oh darn, so that actually makes sense.
Yeah, I know, it's crazy, huh? $12,000. And the mode is $9,000. Mode. And mid-range is high plus low divided by 2. Crazy kids. So 59 divided by 2, 59,000. 3. 29,500. So we're not really gonna be talking about like which one is the best representation, but later on we'll be like, okay, what does this 20,000 mean? What does this 12,000 mean? What about 9? What about 29,500? So we'll be talking about more of those later. And that is basically everything in 3.1. My little button.